Whenever you open an app, click a button, or even type a password, something is executing instructions. That something is the CPU. If you want to understand malware, exploits, reverse engineering, or even why bugs exist, you must understand how the CPU thinks. So in this video, we'll break CPU down so simply that even a non-technical person can explain it to someone else. CPU stands for Central Processing Unit. Think of CPU as a worker whose only job is to read instructions, do exactly what they say, and repeat this whole thing billions of times per second. CPU doesn't understand English, icons, or apps. It only understands very tiny instructions. Everything from YouTube to hacking tools become CPU instructions in the end. An instruction is a very small command, like add two numbers, move data from memory, compare two values, jump to another instruction is also an instruction. That's it. CPU don't know login, file, or any virus. They only know things like add, move, compare, and jump. For example, if you write A is equal to B plus C, and CPU sees something like, let's load B first, then load C. Let's perform the operation add, and let's store the result in A. So if you see this load, add, and store, what CPU does. This is why malware also looks boring at CPU level. Just instructions, nothing else. Inside CPU, three things matters most for us. First one is registers. Registers are very tiny, very fast, stored inside the CPU. If memory is a cupboard, registers are what you are holding in your hands. CPU can only directly work on data inside the registers. Then the second thing is ALU, Arithmetic Logical Unit. ALU is like a calculator. It performs additions, subtractions, comparisons, all types of arithmetic operations. Then the third thing is control unit. This is like a manager. This is like a manager. It decides which instruction to run, in what order, what to do next. CPU works in a loop called instruction cycle. No matter what program you run, it always follows this cycle. And this cycle contains 4 steps. First one is fetch. CPU fetches the next instruction from the memory. Then the second step is decode. CPU figures out what is the instruction, what data it needed. Then the third one is execute. CPU actually does the work, add, compare, move, etc. that we have discussed. And then the fourth step is store. Just like we saw in the example of addition. Result is stored back either in the memory or registers. Then CPU moves to the next instruction. This happens billions of times per second. The same thing: fetch, decode, execute, and store. CPU needs to remember where it is in a program. That's the job of program counter. Program counters stores the address of the next instruction. Normally it's just move forward, but instructions like if, loops, function calls, they change the program counter. If someone controls the program counter, they can control the execution. Then most serious security bugs happens in the CPU only, not in the fancy UI. For example, buffer overflows. These are nothing, just overwrite instructions flow. Exploits. It means change what CPU executes. And many of you have heard about malware. It means hides inside normal instructions flow. When hackers say control execution, they mean control what instruction the CPU runs. Cybersecurity is not a magic. It's abusing how CPU blindly follow instructions. So today we learned CPU is just a fast instruction executor. Instructions are tiny and simple. Everything runs in fetch, decode, execute loop. And control over execution is equal to power. In the next video, we'll talk about memory hierarchy and why faster memory can also be more dangerous. That is what most real-world attacks begin. And remember, we'll keep it simple.